Hello friends, good evening. Let's start with today's discussion on Oracle Lab regarding joining. Okay, how to do joining of two or more than two tables by the help of SQL command. I already discussed about the joining and different types of joins and why the joining is required. Okay, all these things in uh, in our previous lectures in the theory classes, right? So today I'm going to show you how we can do those joining. I have already shown how we can use relational algebra to do joining. If you remember, I told that joining means we can join more than two table or more than one table or more than two table together to get a some joint information or common information. There are various sort of joining I have shown in my theory classes, like Cartesian product. I have shown the cross sign is used for relational algebra to show the Cartesian product. Then I have shown the the natural join. I have shown outer join, full outer join, left outer join, right outer join. So these different sort of joining I have shown, right? Then natural join means equijoin or inner join. The same. The natural join is also known as equijoin or inner join. These are the various sort of joining. If you forget it, I suggest you to revise the class notes, class materials which I have discussed regarding joining. I have given each and individual discussion with example of tables. Okay, so you can get the idea. So if you forget, don't worry about it. I am going to discuss it once more based on the on our lab simulator, Oracle Lab Simulator. So let's go to our online Oracle Lab Simulator first, which I already told in the last class that in Oracle Lab Simulator we are going to discuss it, right? So here, this is a SQL live SQL Oracle Lab Simulator. In the Oracle Lab Simulator, I have created for the joining operation. I have to create minimum two tables, but I have already told one more than one or more than two tables are used to join. So in examination, they will generally give two tables joining, or maximum if they will give a question, they may use three tables joining. Okay, not more than that. So in lab, I can also use two table, or I can also give a question on three tables joining. So for sake of simplicity, I have created two tables here. That is table for customers and table for orders. Okay, with orders. So customer table has a customer ID, which is a primary key, customer name, age, address, and salary. So to make the table simple, because our main motivation here to show the joining operations, so I don't make all these columns full with different sort of constraint. Only the first column that I have to give, because joining require one primary key, and that is important if you remember it. Now in the same way, I have put it some record here, some six or seven records of customer table. In the same way, I have created an order table which consists of order ID, order month, customer ID, and amount. Okay, so let's first check this tables first. What are the values are there in this customer table, order table? Let's take the customer table first. So select start from customer. Order by means in this software, the output are coming in haphazard way, in random order. So that's why I make it order ID based on order by clause. It's a sorting of the order ID in ascending order. So based on that, the table information has been given. So you can check here. Total seven information, seven records I have inserted with the defined value. Right. This is the customer table. Now in the same way, I will check the orders table, order new table. Please remember ID, name, age, address, and salary of this customer table. Let's check the orders table. This is the orders table, which will consist of order ID, order month, order customer ID, and amount. Okay, these four attributes are there, and they are also four records inserted into the order table. So let's start with the joining operation. So what is SQL join? SQL join clause is used to combine records for two or more than two tables in a database. A join is a means for combining fields from two tables by using value common to each other. So one condition, if you remember, I told during my theory class, one condition should be you have to maintain that there should be one common column in both the table, and that column should be the first table, the column should be a primary key, and for the next table the column will act like a foreign key. So in case of lossy join, and there is a concept of lossy decomposition join and lossless decomposition join. I already discussed in the class. So instead of lossless, you can choose non primary key column for the joining, but that should be a lossy joining. But in case of lossless, if you follow the lossless join decomposition, you have to choose a column with a primary key of one table and non-primary key of the same column non-primary key in the another table. So if you check in our cases, I have already in our cases I have already created the table. If you check the tables here clearly, the customer table and orders table, orders new table. In this table, which column is common? The column is common is actually this customer ID. This column is common. Okay, common, not common actually. Based on some common column, we have to join this table. Okay? These two tables should be joined based on some common column. Okay, so this ID name may be different, but the values are similar. Okay, this is the value 3234. This is the orders ID value, and if we check the value for the customers table, how it will look like? If you check the customers table here, we run it. Sorry. So you will get the ID value. The same value is there in the orders new. You will find the value of the order ID, customer ID is 3324 like that. So these all values are present here. So these two columns are similar in both the tables. So when we are going to join these two tables, we require this thing. Now the thing is that there is there are the different types of joining are present. The first type of joining that we are going to do, that is a very common and simple joining, which is called a Cartesian join, a cross join, which returns the Cartesian product of the sets of records from two or more join tables. Thus it equates to an inner join where the join condition always evaluates to either true or where the join condition is absent or from the statement. So Cartesian join is actually, it is a joining of the tables of these two tables, which will join all sort of possible combination. It may be the same record will be repeated for both the tables. It will not filter out the information after joining the two tables. So this sort of joining is called Cartesian product. It makes a joining of information, or you can say the union of information of the two tables. Okay. So the basic command you have to write in Cartesian product: select table one dot column, table two dot column, and dot 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 from table 1 comma table 2 and so on. So how we can write the Cartesian product? Let's check. We are writing the joining command of the Cartesian product in this way. Very simple. We'll write select ID. ID means the customer ID of the customer table, name, amount, and order month. Order month is from the orders table, and amount, name, and ID is for the customer table from customers and orders. This is the only joining operation. We are not using any join keywords here, any sort of funda here. We just simple write the two tables one by one by using commas, and write the common column from both the tables. Okay. Here we are not following any common IDs, that common column we have to use for customer table orders new. That is applicable for all the other case of joining, but in the Cartesian product, it is a just simple join without look after the repetition of the records. And that's why it is not real in real life. It is not generally used because repetition is not at all acceptable, or redundancy or data is not at all acceptable. That's why we are not using this sort of Cartesian join or cross join in real life, right? So let's check the output of this command. So you will check, it will give you all possible combinations of both the tables. So you will check that there's a huge number of repetition of the same value, and this Cartesian product means crossing of one value to another. So in relation algebra, when I took the lecture of relation algebra or relation algebra joining in relation algebra, I discuss about the details of this Cartesian product. Okay, so the same thing can be done by the SQL query in this way. Now we will check the next type of joining. Cartesian product is over. Now we'll check the next type of join is equi-join or inner join. That is the most interesting join in relation algebra. It is also called natural join. So the most important and infrequently used join is inner join, which has been already I told. And inner join creates a new result table by combining column names of two tables, table 1 and table 2, based upon the join predicate. Okay. The query compares each row of table 1 with each row of table 2 to find all pairs of rows which satisfy the join predicate. Okay, so the query compares, it compares each row of table 1 with each row of table 2 to find all pairs of row which satisfy the join predicate. There is a join predicate is there, and which satisfy, based on that satisfaction of join predicate, it will compare each row of table 1 and each row of table 2. When the join predicate is satisfied, column values for each matched pairs of row A and B are combined into a result. Okay. So let's check how the inner join or equijoin command has been written. Select table one dot column name, table two dot column name. Why table one dot? You can use table one dot this symbol, or you can directly use the column name of the table. Automatically the column names are different. That's why we don't need to use, if the column name is same. Suppose the customer ID we're using for both tables, then we have to use table one dot column name. Column name, that means we'll write customers dot customer ID and comma we'll write orders new dot customer ID in this way. So that's why to remove the confusion, I am using two separate different column names in both the cases, right? But their value may be same. So that's why we can making an equal. We can match it. This is a join predicate, right? So here from table one inner join table. This inner join term is optional. You may give, you may not give. From table one comma table two is also do the option by default inner join, right? On table one dot common field equal to table two dot common. So I have already told we require joining must require apart from the cross join or Cartesian product, all sort of joining must require a common field that present in both the table. So in customer table, in our case in customer table, a customer ID is matched with the orders table only ID field. The customer table ID field is matched with the orders table customer ID, right? So the common field will be there. So table one means here we will write a customers dot ID equal to orders new dot customer ID. There's a table one. So we'll just write the command, whatever has been written here, we'll write it. Okay, we'll omit that one. Omit means we are not going to write inner join. Okay, you may try at your home by writing inner join. If we omit inner join, I have already told we can. It will by default consider it as the inner join operations. Okay, but you have to remember there should be a matching predicate, join predicate, that according to the definition of the inner join, there should be a join predicate. This join predicate is nothing but this one. Okay, the customer dot ID equal to orders new dot customer ID. Okay, so we actually fetching ID, name, age, amount from both the tables. Okay, suppose ID and name is from first table, ID, name, and age, and amount is from second table. So from customers and order new from both the table, where customer dot ID and orders new dot customer ID. These two are same. I have already discussed during the creation of the table customer ID, and these ID values are similar. Okay, so these two are the same column but with different name. So that's why I have used to identify it. I have used this column name. That is important. Table name should be there along with the column name. So if we run it, this is the output of this case. So if you check the two tables, these are the two tables, and if we are performing the equijoin operations, okay, here in case of date I am using month in my table orders new, and names are quite different but more or less values are same, right? So if you use a natural join here or equijoin here, so we will choose based on this common column. Which one is the common column? This is the common column ID, customer ID, and this is the customer ID of orders. These two columns are equate. Okay, this is the column and these two columns, the common column are equate, right? So if you equate, so 3324. So obviously this 33 will match with this 33. So this 3 is match 102. So 102 is the order ID. So how many columns will fetch in our 4 columns? ID, name, age, amount. So let's go back. ID, we will get ID from the customer ID, but that ID should be similar with the customer ID of the orders new. So orders new customer is 3. So here the ID 3 is regarding Kaushik. So name will be Kaushik will be fetched. ID 3 will be fetched. And what are the other columns? Age and amount. So age, what is the age of Kaushik? 23 will be fetched, and amount, this is the amount, 3000 will be fetched of corresponding Kaushik. In the same way, there is customer ID 3 is there, but there may be a Kaushik will be repeated again. But the thing is that their order ID is different. So Kaushik can make an order of more than one item. So that's why the transactions are quite distinct. Okay. So again 100, again Kaushik, order customer ID 3, age 23, and amount is 1500. Okay, let's check the output. Okay. So Kaushik is fetched 2 times. Clear? I think your conception will be clear. In this way, we will match the next one. There's 2. There's 2 will be matching with this one. So Kilan will be fetched, 25 will be fetched, and 1560 will be fetched. Let's take the output. Kilan 25 and 1560. And last one is Choitali, because of these 2 columns are matching. So that's why, because of these 2 columns are matching. So that's why these four columns, these four rows are matching based on the customer ID, the common columns of these two. So that's why four records has been fetched. That is the job of the inner join or equi join. So let's come back. Let's move on to the next join, which is a full join. In my theory class of relation algebra, I discussed it as a full outer join, and there are two types of outer join. Full outer join, and within that full outer join is a left outer join and right outer join. If you remember, if you forget it, please check the materials that I have discussed during my class. So in full join combines the results of both left and right outer join. So let's first check the left outer join first, and then we will check the full outer join, right, and then full. What is left outer? The SQL left join returns all rows from the left table, even if there are no matches in the right table. Right. So I have told, if you remember, I told during my class that in left outer join or left join, the left hand side table should be intact, and the right hand side table, the missing values of the right hand side table should be replaced by null. Remember, so even if there are no matches in the right table, this means that if on clause matches 0 records in the right table, the join will still return a row in the result, but with null in each column for the right table. Clear? Null means blank value. Here in this software, we have checked in the last discussion, we have checked the null will be replaced by dash here, will be represented by dash here in this software. Null is not written here, represented by dash. The same thing. So the left join, how to write the left join? The same command like inner join, equijoin. Only instead of inner join written here, we will write the left join. But this is not optional. Optional is inner join. By default is inner join. So left join, right join, full outer join, you have to write specifically here. Okay, that is important. So let's run the command of left join. This is the command I have written for you for the left outer join. So just run the command. So what I've told in left outer join, the left table will be remains intact and the right table will be replaced by null. So this is the left table, because in left outer join, if you check the command, again fetch these four columns, and the left table is customer, the first table is the left table, full join, the right table is orders new. So the missing information of the orders new will be replaced by the null value here, dash value. So run it. So this is the output you will get. So 5 Hardik. So here the left table is intact. So what are the columns we are fetching from the left table? ID and name. If you remember it, these are the tables. So ID and name we have fetched from the left hand side table customers, and from the right hand side table we will fetch amount and order month. Order month, this is the order month. I have been replaced in my table as the order month in case of date, and amount have been replaced here. So the matching, that means the value ID and name will be intact at the left hand side table. So all the 7 records will be there with all the 7 names, but the record, the customer ID which are matching, only these records they will fetch from the right hand side table, and rest of the records will be replaced by null. Okay, so Kaushik, Khilan, and Kaushik, Khilan, and 4 means Choitali. These 3 records are full with the value of amount and month. Check it out. Khilan, Choitali, and Kaushik. Am I clear? So these 4 records will be matched with the value of order month, and the rest of the records will be replaced by null. Here null represented by dash. Okay, in this software the null is represented by dash. A similar thing, null and dash in this software. Clear? This is the left outer join. Now we will do right outer join. The same option we will do, only we'll do instead of left we will write here right. Do it. In right outer join, so luckily we don't get any value at the left hand side which is replaced by null. In right outer join, the right hand side table should be intact and the left hand side table should be replaced by null value. Right. Is a right join. Okay, just opposite of left outer join. So in this case, in case right hand side table we are fetching order month, we are fetching order month and amount from right hand side table. Right hand side table is this one, order month, and this is order month and amount. So these two should be similar. Okay, based on this common column, because common column I've used here. This is the common column, customer ID and orders new customer ID. So these two common columns should be matched, and based on that matching columns, will fetch the values of right hand side table intactly. Only left hand side tables value which are not present here will be replaced by A. So right hand side table only 4 values. Obviously left hand side all 4 values are present. So that's why there is no null symbol at the left hand side table. Now we will do the same operation for the full join. Full join is nothing but a combination of left outer join and right outer join. So you will get the combined table of both right outer join table and the previous left outer join table into a single table of full outer join. This is the resultant table of full outer join. You will check it out. This is the combined table you will get. This is the combined table you will get. Okay, the left and right both combined table you will get. Okay, into a single table. So this is all about the joining, various types of joining, and how you are running your SQL command, how you're applying your SQL command to get the idea of about all these joining. So I suggest you to practice, create your own tables and practice as maximum as possible regarding the joining. In our next lab session, we are going to discuss about the one of the very important concepts which will take the help of joining to overcome the problem of this command, which is called a subquery. That means nested query, query within query. So more than one query we will write to fetch a particular objective, right? Based on the developer's choice or customer choice. So that's all for this lecture. So thank you for watching this lecture, and please go through all the lectures properly and try to match with the notes of the books, and as well as my online website. Follow my online website. And thank you very much.